Today we will be demonstrating new networking technologies in Microsoft Server vNext as part of our software-defined networking stack. On the screen you will see a generic three-tier application. A hoster can onboard multiple tenants' virtual applications as virtualized components consisting of, for example, a web tier, a middle tier with business logic, and a database tier. As you can see, these three tiers are segregated into three virtual subnets. Each of these virtual subnets can have ACLs defined at the virtual network layer or at the individual vNIC layer. A distributed router, which is embedded into each Hyper-V host running the VMs, is used to connect these three virtual subnets. The distributed router is also able to connect these virtual subnets to external networks using a virtual edge, providing site-to-site connectivity via IPsec, VPN, or GRE tunnels. These S2S gateways enable a tenant to run part of his or her workload in Microsoft Azure public cloud or on a service provider's cloud. Using third-party appliances, we are also able to connect virtual networks to physical networks within the same subnet or across subnets. The network controller is able to receive RESTful northbound API calls submitted by a tenant or a hoster to define policy. These policy is then enforced and plumbed down through a southbound interface to the hosts themselves. An inbox L4 software load balancer is able to distribute traffic across multiple DIPs in a highly available configuration. Other capabilities not directly shown in this slide but provided in Server vNext include QoS and NAT gateways, among other things. We will now discuss two specific tenant workloads. The first tenant has virtualized her e-commerce web application to take advantage of the benefits of virtual networking. The second tenant has also virtualized his application, which supplies video streaming and provides for different levels of quality of service. This physical network topology that you see contains the logical networks that make up the two tenants' workloads. On the left-hand side, we see that there are two CloudShop tenant VMs as well as two Contoso client VMs. Each of these access their respective services through a VIP, which is advertised by the BGP router. A software load balancer then takes these connections and distributes them across the front-end IIS web servers in the first tier of the application. The three physical hosts that you see on the right-hand side of this screen host the tenant VMs themselves. The first four in this column here represent the IIS web front-end servers of CloudShop's network. The next three IIS web server VMs here represent Contoso's front-end web application. Moving to the back end, we have a database tier which supports CloudShop's application. And lastly, another IIS VM instances which store the video content and distribute it. CloudShop's logical network looks as seen on the screen in front of you. Clients can access the service through a VIP address advertised by the BGP router and then distributed using the software load balancer across four DIPs which are hosting IIS web applications. This web application is the front end to the service. A back-end database tier hosts one instance of a SQL virtual machine. These two virtual subnets are connected to a distributed router as mentioned previously. Policy is defined by the tenant and enforced by the network controller by pushing it down to the individual hosts. We will now demonstrate this simple application which allows for a user to select specific products and add them to the cart. After adding several items to the cart, we will now demonstrate this simple application. A user is enabled to select products which he or she can add to the cart. After we have selected several products to add, we will then click the checkout and see these products in the shopping cart. We can also remove the products from the cart. This ends this tenant's demonstration. We will now look at tenant 2, Contoso's application. This logical topology is similar to the previous CloudShop topology. It also has a software load balancer, which is able to distribute traffic flows across 4 DIPs, which are running IIS web servers. The backend here, instead of being a database SQL server, is actually an IIS web application which hosts video content for which a user can stream. In this demo, we show 2 users which at this time both have gold QoS profiles enabled. You can see the smooth streaming video in both screens. We will now apply a QoS profile, a bronze profile, which assumes that a user has decided to downgrade his or her service. We will reset the connection and show that the left-hand user's screen continues to stream the video properly. However, there is buffering that is occurring in jitter in the second user's screen. We will now apply a firewall ACL policy which will block that user's traffic. This may happen in the case where the user has failed to pay his bill or is trying to do something malicious against the website itself. As you can see, the right-hand user screen is completely blank. This ends this demo.